Hello, welcome all my dear friends. This is a question from exercise 8.1. Now it is the maths of class 9. You remember this is class 9. I have started class 9 today. So this is the first question, revision 1 chapter for class 10 general maths. Question is find the approximate value of root 2 correct to two decimal places using the method of square root. So we have to find the square root of 2 actually. Square root of 2. We know the square root of 4 is 2, 9 is 3, and 16 is 4, like this. But what is the square root of 2? And answer should be correct to two decimal places, so the number will be up to two decimal. Okay, so in this type of maths, you have to give zeros, sub zeros, even number of zeros. You see, I have given 6 zeros, even number of zeros, either 2 zeros, 4 zeros, 6 zeros, like this, not 3, 5 and 10, 9. So now to find the square root of these types of method, you make pairs. You see the 0 0 1 pair, 0 0 1 pair, 0 0 1 pair, it is not pair. Now you have to write two same number in these two places. Same number. If you write 2 to the 4, it will be greater than 2. So you have to use number 1 here. 1 1 ja 1 you write. Now you subtract. 2 minus 1 is 1. Then you see the decimal sign is given. You give the decimal sign here. Now you take 2 0 here. I have taken this 2 0 here. Now what to do? You have to write a number here which is double of that number. What is the double of 1? Double of 1 is 1. Now you have to put two same number here. You understand clearly what I am telling. That is the main thing. Here we have to put two same number here. You have to write two same number here such that their product becomes near about to this. Suppose I have written here 5 5. If we write here 5 5, if we multiply, it will be 125. Here you see it is 100. 5 5 will be greater than this, so you write here 4 and 4. And if you multiply 24 into 4, it will be 96. Here you write 96. Now subtract, it will be 4. After subtraction, it will be 4. Now again you take two number here. Before that, whatever you have written this number here, you have to write this number here also. Now you see it becomes 400. Now you have to write a number here. Here you have to write a number which is double of that. Double of whatever is given here without decimal sign. This number is 14. So its double will be 28. Here you write 28. Okay. So if you write here 28, and now you see you have to put two same number here again, so that you have to get near about to this, not more than this. So if we write here 2 2, it will be more than 400. So you write again 1 1. So if we write here 1 1, it will be 281. This one should be go there. Okay. So here you write 281. Now you subtract it. It is 90, 300, and then 1. Okay, now you again you write the same number here. That is 2 zeros. You have to take it here. Now here you write the double of that 141. 141 double is 282. Now you put two same number here so that it is just near to this 9. So 9. If I write here 5, 5, 5, then I write here 4. 4 4 is 16, 6 remaining 1, 4 2 is 8 and 1 9, 4 into 8 32, 2 remaining 3, 4 2 is 8 and 3 11. You see it is 11296. If we write here 5 5, it will be more than that. So you write here 4. If 4 will be go there, and here you write 11296. And no need to subtract it because here already I have written three numbers after the decimal sign. But in your question, you have actually write two numbers after the decimal sign. So the square root will be, you write square root of 2 is, you write 1.41. You don't write this 4 here. We have written this 4 because whether this number will be same or more than that. If you get more than 4 here, that is 5. If the number came here as 5, then 1 will be 2. But since it is less than 5, it remains same. So answer will be 1.41. This is the square root of 2. Okay. Now Second question of same chapter exercise, and that is revisional exercise class 9. Question is write two irrational number whose sum is a rational number and whose product is also a rational number. First you have to know what is irrational number and rational number. Rational number means any number is in the form p by q, where q not equal to 0 is called rational number, and irrational number is any number which cannot be expressed in the form p by q, that is called irrational number. So here we have to take two irrational number so that their sum becomes rational, and if we again if we multiply these two irrational number, the sum becomes rational. So suppose you can rewrite let 2 plus root 3. You see, this is an irrational number because here root 3 is there. And 2 minus root 3 are two irrational number. Okay, therefore sum is their sum, you see, 2 plus root 3 plus 2 minus root 3. Here you see root 3 cancel, so you will get 4. This number 4 is rational. 4 can be written as 4 by 1, so it is rational. Similarly, their product is what you see, product. So first number is 2 plus root 3 and second number is 2 minus root 3. You see, this is in the form of a plus b into a minus b. It is a formula of a plus b into a minus b. So a plus b into a minus b, we know a square minus b square. So a is here 2 and b is here root 3. So here you write 2 square minus root 3 square. You will get 4 minus 3, that is equal to 1. You see, sum is also rational and product is also rational. So here you have asked to find two irrational number. You write the two irrational numbers are 2 plus root 3 and 2 minus root 3. Okay, so we have completed this one. Now question number 3. Question number 3 is write the integers in between minus 5 and 5 on the number line. You know what is the number line? Suppose this is a number line. In the number line the midpoint is 0, and in the right side of this line all are positive numbers. Suppose this is 1, this is 2, this is 3, this is 4, and this is plus 5. Okay, in the left side of this number all are negative numbers. Suppose this is minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, so I have written all the numbers from 5 to minus 5. Now you have to write the numbers which are in between minus 5 and 5. Means you don't write 5, you don't write minus 5, and you write down the middle numbers. So you write numbers are minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. These are the numbers which are lying between minus 5 and 5. Okay, so we have completed this one also. Now question number 4. By the law of indices, we know the formula is a to the power m divided by a to the power n is a to the power m minus n. If in this relation, if m equal to n, prove that a to the power 0 is equal to 1. So you write a to the power m divided by a to the power n. You see the condition is given m equal to n. So in place of n you write n divided by a to the power n. Okay, why we have written here n? Because it is given m and n are equal, that's why. Okay, now you see in case of division, the first number will go in the above and the second number will come into the denominator. Okay, now you see a and n cancel, so it will be 1. So you see a to the power m divided by a to the power n becomes 1 if m is equal to n. It is m. Okay, so we have completed this one also. That is, we have proved. You see a to the power n divided a to the power n. A to the power n divided by a to the power n means a to the power n minus n. Okay. In case of division, you see formula is given a to the power m divided by a to the power n is a to the power m minus n. So a to the power n divided by a to the power n will be a to the power n minus n, and a to the power n minus n will be 0. A to the power 0, it is also 1, or you write a to the power n by a to the power n is 1. So this is the answer. Next, number 5, question number 5 is given a to the power m divided by a to the power n. Here you see, we know its formula is a to the power m minus n. A to the power m minus n, you write a to the power m minus n is given. I have written it from here. Now you see, m is given 0, n remains same. So this can be written as a to the power 0 by a to the power n. Since a to the power 0 means 1, so you write 1 by a to the power n. So you see, we got a to the power minus n. This is actually a to the power minus n, and it becomes 1 by a to the power n. Okay, so we have completed this one also. Now question number 6. Here you see, question 6 is given, find the LCM and HCF by using prime factorization method. So prime factorization method means you divide 3 to 1 by the smallest number, 3 1 is 3, 0 and 7. And 396 can be written as 396, 3 1 times, 3 times, 2 times. Again by 2 we can divide it, 2 6 is 12, 1 remains, 2 6 is 12. Again by 2 we can divide it, 2 33. Again by 3 we can divide it, 3 into 11. Is it divisible? No, it is a prime number, so it cannot be divisible by any other number. Therefore you write 3 to 1 can be written as 3 into 7, and 396 can be written as, you see how many 3 are there? 2. How many 2 are there? 2. So you write 2 square into 3 square into 11. Okay, you see 2 can be written as 2 square, 3 can be written as 3 square into 11. Now you write HCF. You see, in between these two terms, here 3 is the smallest, here 3 square is the greater one. So always in case of HCF, always you choose the smaller one. 3 and 3 square, 3 will come. So that is the answer of HCF. Now if you have to find LCM, in between you see, here 2 square is there, it is not present here, so you have to be right. Common and uncommon both will come in the LCM. So 2 square I have written, in between 3 and 3 square you write 3 square, then you write 7, then you write 11. So 2 square is 4, 3 square is 9, and then 7 into 11 is 77. So what is their product? I am multiplying here, 42 to 4 remains, 6 7 is 42 and 4 46. Here 3 7 is 21, 1 2 remains, 3 7 is 21 and 2 23. So 2 6 1 7 4 3 7 2. So answer will be 2 3 7 2 7 7 2. This is the LCM and that is the HCF. So that this is the question asked here. 455. You see, these are the two numbers given. We have to find HCF and LCM. So first we are taking 455. It is, since unit digit is 5, it can be divisible by 5. So you divide it by 5. 5 9 ja, 5 1 ja. Again it can be divisible by 7. We know the table, that's why you write directly 7 into 13 is 91. Now 42. 42 is an even number. Even number is always divisible by 2. So you write 2 into 21, and now you divide by 3. 3 into 7. Now you write what you have got here. 545 means 5 into 7 into 13, and 42 can be written as 2 into 3 into 7. Therefore HCF will be, you see HCF, the common terms here, 7 7 is there, 7 is common in both, so 7 is the HCF. Now you find LCM. LCM is common and uncommon. You see 7 is common in both, you write first 7. 2 is not common in both, you write 2. 3 is not common in both, you write 3. 13 is also not common in both, so you have to write 13 here also. Now multiply 7 3 ja 7 2 ja 21, 21 3 ja 63 into 13. If you multiply 13 3 ja 39 and 3 remains, 13 6 ja 78 and 3 79 80 81. So this is the LCM. So we have completed this one also. Now another one, 408 and 170, we have to find their HCF. So divide it by prime factorization method. We are dividing this one by 2 by 204 times, 102 times, again by 2 it will be 51 times. 51, it is a multiple of 3, so you write 3 into 17 times. Now 170 can be divisible by 2, it will be 85 times, again by 5, you write 17 times. Now you write 408 means 2 3 times, you write 2 cube into 3 into 17. Here you write 170. It can be written as 2 into 5 into 17. So HCF is, you see 2 cube and 2. The smaller one is 2, you write 2. Now 17 is common in both, you write 17. So their HCF is 17 to 34. Now you write LCM. LCM is in between 2 cube and 2. You have to write down the larger one, 2 cube. Then you write 3 is uncommon in both, so 3. 5 is uncommon in both, so 5. And 17 is common in both, so 7. So it can be written as, you see 2 cube is 8. 8 5 j is 40. 43 j is 120. And you have to multiply it by 17. So multiply 17 0 17 2 ja 34 4 3 remains 17 1 ja 17 and 3 20. So this is the LCM. So we have completed number 6 also. Now question number 7. Where is 7? Question number 7 is, I am writing this question here. We have to write number 7. We have to write 2 by, in between 2 by 11 and 1 by 6. We have to write to that is rational number. Okay, so we do one thing, 2 by 11 and here you write 1 by 6. You multiply it by 6, you multiply it by 6 and you multiply it by 11. This is also multiplied by 11. It becomes 12 by 22, 66. And here you can write 11 by 66. So you see, we are unable to find two rational number in between these two because they are serial. Now again I am trying for another thing. It is given 12 by 66. You multiply it by 2. This is also by 2. You multiply it by 3. Then we will get 3, some rational number between this. This is also, you multiply it by 3. So upper number is also multiplied by 3. It becomes 36 by 198. And it becomes 33 by 198. Okay, now you see this is 33 by 198, it is 36 by 198. So the medium rational numbers will be, one is 34 by 198, another one is 35 by 198. Okay, so these are the two rational number between these two. It can be done in other way also. Suppose these are the two numbers given. So you write 2 by 11 plus 1 by 6 divided by 2. 2 means we can find the middle number. So how you see, their LCM is 66. 11 6 times 6 to the 12. And here 66 11 times you write 11. Here you write 2. It can be written as 23 by 66 divided by 2. It means 23 by 66 into 1 by 2. So the medium number is 23 1 is 23, 66 into 2 is 132. So between these two number, one number will be 23 by 132. Okay, actually your answer is completed here, but if you want to do in another way, then you can do it like this. You take the sum of these two number, then divided by 2. What you will get, it will be the middle number. Again, if you want to find any other number in between these two number, so you take the sum of these two number, again divided by 2, like this one, you will get a number here. If you want to find one number in between these two numbers, you take the sum of these two numbers divided by 2, you will get another number. So similarly, you can find infinite number of numbers in between two decimal numbers. So this is the system. Okay, thank you. I have completed up to question number 7. Later will be done in another video. Before completing my video, I am cordially requesting all of you to subscribe my channel and press the bell icon for the latest update. Please comment and like and share of my video, those who are reading in class 9. Thank you. Good night.